Let's see why 99% of accuracy is not good enough. Now you might wonder, 99% is good enough, but it is not good for our model while it has skewed data or class imbalance. Let us see what are the problems and why 99% of accuracy is not good enough. When you build a model for classification, you always want to look at the accuracy of that model as number of correct predictions from all predictions made. This is called classification accuracy. Once you have a model that you believe can make a robust prediction, you need to decide whether it is a good enough model to solve your problem or not. Classification accuracy is typically not enough information to make this decision. So if you are looking for small population in large dataset, you need to know how reliable your prediction is. It is highly dependent on reliability of data you are starting with. So for example, if you are looking for 1 in 1000, then 99% of accuracy is not good enough because 90% of the result will be biased. When not to use accuracy as evaluation metric. If you have a class imbalance problem, then you should not use accuracy as your metrics. What is class imbalance? When the class distribution is slightly skewed, then accuracy can still be a useful metric. When the skew in the class distribution are severe, accuracy can become unreliable measure of model performance. For example, if we take fraud dataset, the majority of class represents not fraud transaction and minority class represent fraud transaction because fraud not usually happens. Generally all transactions are not fraud and in rare case fraud happens. So there is a class imbalance in fraud dataset. Good performance on minority class will be preferred over good performance on both class because we need to detect fraud for our model. It is important to predict the fraud transaction rather than predict not fraud transaction. So we will have to consider the most important thing to predict for our model because to detect fraud is more important than not fraud. Many machine learning models are designed with assumption that our dataset is balanced distribution, but it is not. So we need to apply visualization analysis technique to see whether our dataset contains balanced distribution or not. Because machine learning models thinks that our dataset are balanced only, but actually it is not. So it always predict the majority class, causing them to achieve high 99% of accuracy, which is not good enough. Instead of correcting faulty prediction, it is better to use another evaluation metrics to summarize our model performance for imbalance classification. There are many another evaluation metrics are available like ROC curve, F1 score, RMSE, MSE, mean square error, etc. So here is the look of our fraud dataset. Here you can see that the majority of the transactions are not fraud and only 2% are fraud. So in this case we can't use accuracy as an evaluation metrics for our model performance. You can see accuracy of our model class wise also. Here you can see not fraud equals to length where y equals to 0. Here y equals to 0 is classification categorical variable in our classification model, where y equals to 0 means not fraud, y equals to 1 means fraud. So length divided by total number of values into 100. So it will give percentage of our accuracy class wise. You can see here class 0 means not fraud transaction gives 99% of accuracy, while class 1 gives only 0.99% of accuracy. So it is not good enough to use accuracy as an evaluation matrix for our model performance when there is a high class imbalance. Where it is useful, accuracy only makes sense when answers are in binary. For example, fraudulent transaction, which will classify our prediction into fraud or not fraud. Both can be possible in one transaction. Another example is diagnosing tumors, preventing spam mails, classifying it into spam or not spam. For non-binary problems like predicting stock prices, detecting object, recommending a product, translating a document, translation of audio into text, in this type of example, there are other metrics which are useful for non-binary prediction. So accuracy can't be used for non-binary problems. Thank you. If you liked my video, then don't forget to like, share and subscribe my channel.